Hi everyone, my name is Henry, and today I'll be explaining nodal analysis, one of the most useful circuit solving techniques in engineering. What is nodal analysis? Nodal analysis is the method used to find voltages at specific points in a circuit, known as nodes. It is based on Kirchhoff's current law, which says that the total current entering and leaving a node must be equal. By applying this rule to each node, we can form a set of equations that describe the whole circuit and solve for the unknown voltages. Example circuit. His example circuit we'll be using. It has 12-volt source on the left and three resistors. Resistor 1 is 2 kiloohms, resistor 2 is 1 kiloohm, and resistor 3 is 3 kiloohms. We'll be focusing on two unknown nodes called node A and node B. Choosing the reference node. Before starting, we select a reference node, also called ground, and assign it a voltage of 0 volts. Every other voltage in the circuit will be measured relative to this point. In this case, node C makes the best choice because it connects to multiple branches and acts as a common return point, or path for current. Applying Kirchhoff's current law. Now we apply Kirchhoff's current law to each node. At every node, the sum of currents leaving the node equals the sum entering it. We will write one equation for node B and one equation for node B are based on the currents through the connected resistors. This is the foundation of nodal analysis. Using Ohm's law. Next, we use Ohm's law to express each current in terms of voltage and resistance. For example, the current through a resistor equals the voltage across it divided by the resistance value. This allows us to express all the unknown circuits in the node equation using only the node voltages. Writing the node equations. At node 1, the current coming in from the voltage source equals the current leaving through resistor 1. At node 2, the currents leaving through resistor 1, 2, and 3 must add up to 0. Each of these currents represent the balance of current at each node according to Kirchhoff's current law. Solving the node voltages. Now we substitute the resistance values into our node equations. After simplifying, we find that voltage at node B is approximately 3.27 volts, while the voltage at node A is 12 volts from the supply, and there are two node voltages relative to the ground node. Verification. We can check that our results are correct by confirming that the total current entering and leaving each node equals 0. The current values calculated from the voltages across each resistor balance perfectly, meaning Kirchhoff's law is satisfied and each selection is correct. Advantages of nodal analysis. Nodal analysis works for any linear circuit and usually requires fewer equations than mesh analysis. It's an efficient method that can be automated easily in circuit simulation software such as Multisim and LTS-SPICE. Conclusion. That's a complete walkthrough of nodal analysis, from identifying nodes and writing equations to calculating voltages and verifying results. Thank you for watching my ENGG104 presentation.